afternoon, ma'am, or good morning, ma'am.
Hi, ma'am.
Hello.
Good afternoon,
Well,
ma'am.
anything that works for you,
Yes, ma'am.
Yeah.
Thank you, ma'am.
Okay, guys. So today we're going to be talking about the periodic table. We're going to really dive into it and discuss it, right? If anytime during the call you guys can't see my screen or it's glitchy, then just let me know. Pop it in the comments. Okay.
Yes, ma'am.
All right, so just give me a second to organize my life here. Okay, if you guys want to say something, then you may unmute yourselves and then just mute yourselves afterwards. Okay, let's start with, yes?
Can you hear me, ma'am?
Yes, I can.
Okay, thank you, ma'am.
Okay, all right. The first thing we're going to talk about is the features of the periodic table. So guys, we learned the other day that there are 118 different kinds of atoms known to us in the universe, right? Okay, if we look at a block of gold or nugget of gold, we know that it only contains gold atoms, right? So that's why we call it an element. But if you look at water, water contains hydrogen and oxygen, so we can't call that an element. Any substance that is made from only one type of atom is called an element. Okay, and therefore we also call an element a pure substance because it's only made of one type of atom. All right, we're going to go into the structure of the periodic table. We know that the elements are ranked from lightest to heaviest. Okay, the smaller number on the element tells us how many protons and electrons the atom has. The small number is called the atomic number, and the bigger number is called the atomic mass. So let's see how that looks on our periodic table. Okay. Right, so first off, if you look at hydrogen here, I don't know if it's too small to see, but there's a number 1 here, meaning that hydrogen is...
Ma'am?
Yes?
Can I please be excused?
Yes. Why, Gabby?
I need the bathroom.
Okay, sure. All right, so as I was saying, I don't know if you guys can see clearly, but hydrogen has a small number 1 here, which means that it only has 1 proton and 1 electron. Then the second element, helium. Helium has 2, right? So that means that not only is it the second element on the periodic table, but also it only has 2 protons and 2 electrons. The smaller number is called the atomic number. And if you look closely, I'm going to zoom in onto this thing. If you look at this element, for example, the small number is called the atomic number, and the big number here.
Happened. Something happened.
Excuse me?
Sorry, never mind, ma'am.
Okay. And the bigger number is called the atomic mass. So that's actually how heavy the element is. Okay, I'm just going to accept Gabby here. Okay, moving back to my previous notes, guys. Right, we know that most elements are naturally occurring on the periodic table. In fact, there's about 88 elements on the periodic table which are known to us and which are natural on Earth. Examples of these elements are oxygen, nitrogen, hydrogen. We know those elements and we know that man didn't create them. They just existed on Earth, right? The rest of the 118 elements are scientifically made. So they are made in a laboratory.
Ma'am.
Yes?
Ma'am, please let Amma in.
You
kicked him out.
Yeah, I was informed by Karine that Amma is not allowed to join our Zoom class. Okay, so I'm not too sure why, but for now he isn't. Okay, so as soon as Karine informs me that he is allowed, then I'll let him in. Okay, I will talk to him about this. Okay, so an example of an element that is man-made is plutonium, right? Let's see where plutonium is. It's right here at the bottom, okay? And we can see it has an atomic number of 94, which means that it has 94 protons and 94 electrons. That's quite heavy, hey? All right, the next thing we're going to learn is about rows and groups. I'm going to take you all the way back to the periodic table and we can discuss it. Right. So all the columns going downwards, right, or vertically are called groups. All the rows going from left to right, we just call them rows, all right? But all the columns going downwards are called groups. Who can tell me how many groups there are on the periodic table? So we start from group number 1, then group number 2, and all the way to this group. If you can see it, please write it to me in the chat. "17. Christopher's close. Okay, so guys, there are actually 18 groups, and I'm going to show you why, right? Here's hydrogen, it's group number 1. And all the way in the end is the last group, which is where helium is, which is group number 18. Okay, so remember that groups run downwards from top to bottom, and rows run across from left to right. Okay, so there are 18 groups on the periodic table, but how many rows are there? Yes, Sibu, you may ask your question. Okay, sorry guys.
Sorry, ma'am. Sorry, ma'am. It was a mistake, ma'am.
Okay, I'm just joining the. Okay, then let's look at how many groups we have on the periodic table. How many rows we have, sorry. So remember, rows are going from left to right. So it's 1, 2, 3, 4, 5, 6, 7, and we don't count these 2 at the bottom, right? So there's 7 rows altogether, and there are 18 groups. Now, guys, I'm going to take you to classification of the periodic table. Each group has a name, all right? And it has a name for a specific reason. So let's look at the first group over here. The first group is called alkali metals. Okay, and I'm going to put it there. The second group is called alkali earth metals, and you'll see that they are colored in the same color, right? The third group, from the 3rd all the way to the 12th, we call it transitional metals. Then we skip all the way to the 17th group here, which is called halogens, like halogens. And the last group is what is known as noble gases. All right, these guys are really noble. Okay, so once we've got that down, I want to move on to what each one means, right? If we look at alkali metals over here, they all are in red. These are the most reactive metals on Earth. They are so reactive, if you leave them out in the atmosphere, it can cause explosions and bombs, all right? So what scientists have done is they have contained these elements in specific oils, right? So if they contain in oil, they're not going to just explode like that, right? Another fact about alkali metals is, so they're highly reactive and they need to be stored in oil as they react with gases in the atmosphere and cause explosions. Then we look at the second one, which is alkali earth metals, right? So that's in group 2. And alkali earth metals are also very reactive, but not as reactive as alkali metals. And we look at this section over here, the yellow section. All of these metals here are called transitional metals, okay? And those are the ones that we use in everyday life. That's like copper and gold and zinc, nickel in our coins, right? And those aren't really reactive. They are excellent conductors of heat and electricity. Therefore, in your electricity lines outside, those are made out of copper because they transfer electricity excellently. Okay, and then we look at the 17th group here, and these are your halogens. Now, guys, if you look at the periodic table, I've drawn this black letter, sort of a letter stature here. This divides the periodic table into metals on the left side and non-metals on the right side. That means that all the metals on this side are in a solid form, right? What does solid mean? Solid is like a rock, okay? And then, you know, we have liquid and gas. All our non-metals on this side, they're usually found in a gaseous state, all right? With regards to metals, the only metal that's found as a liquid in room temperature is mercury, okay? And let me show you how mercury looks at room temperature. It's pretty cool. Have you guys ever, you know, played around with mercury or been in contact with it?
I haven't.
You haven't. Gabby asked, ma'am, are you going to send this or have you already? Oh, guys, I've already sent this note, right? So you don't have to worry about it. Okay. I'm just seeing if I'm missing out anything. Right. And the next thing I can tell you guys about this portion, right, of metals is that they are extremely malleable. Now, malleable means when a metal is strong, right? So if you take a hammer and start hammering it, it's not going to break into tiny pieces. It's going to mold according to the shape you want to create, all right? Another thing about malleability is it's flexible as well. Okay, I'm just trying to see if I've missed out anything. Then we come to halogens. I think we were talking about it before. And these nonmetals over here are basically all gases, right? They are in a gaseous state. They are quite unreactive, right? But if they react with alkali metals on the left here, it causes an explosion. All right, so if chlorine has to be in contact with lithium or sodium or potassium, it's going to cause an explosion, right? I don't know if you guys heard of chlorine bombs. Those are also very dangerous. Yeah. Okay, and then lastly, the noble gases. Those guys are noble, so they don't cause any damage, and they are pretty stagnant. They don't do much, right? Okay, as I said, they are peaceful gases. Right, and one last thing, guys. I mentioned that all the nonmetals on this side of the table are gases, but not all of them are. If we look at carbon, carbon is, diamonds are made out of carbon, all right? Coal is made out of carbon. And those are solids, right? Diamond is hard. If we look at phosphorus, that's also a solid. Sulfur is also a solid. Even selenium, that's also a solid. Right, guys. But if we look at this ladder here, where I've created a sort of a barricade, okay? This ladder contains neither metals nor non-metals. These guys are what we call semi-metals, right? So they share some properties of metals, like sometimes they're shiny, and they share some properties of non-metals, which means they're not such good conductors of electricity. And we're going to come to that. Let me just go to the notes. Okay, let's read through this. Properties of metals. So we know that metals are shiny. they conduct electricity and heat, right? They're malleable, which means that they can bend, and if you have to hammer it, it doesn't break easily. They are solids in nature with the exception of mercury, which is liquid at room temperature, and they take up a lot of space on the periodic table. They take up at least 3/4 of the space. All right, let me show it to you guys again. All of this here, all of this and this and this are metals. The small portion of the periodic table, these ones are non-metals. All right. Now let's look at non-metals, the properties of non-metals. Most non-metals are gases. Some exist as solids, example sulfur or carbon, and they are not good conductors of heat and electricity. They're not like metals, right? And they are brittle. They are the opposite of malleable, right? So if you bend them, they're going to break. If you hammer them, they're also going to break. I want to show you guys a small video, a short video actually. It's a really informative video. Just hold on a sec. Okay, I'm going to the place where they have a really nice illustration of this. 9, 10. Okay, so these are just examples of the different types of metals, right? If you look at it, this is titanium. Okay, I'm sure you guys heard of titanium, like the song. And then this is silver, a block of silver. This is aluminium. Aluminium is basically like your foil. Those are, because metals are malleable, right, guys? You can flatten them as flat as foil. This is chromium, and this is gold. Let's see what else I can show you guys. Okay, let's look at conductivity of metals. If we have to put copper or gold, right, in an electric circuit, it's going to conduct electricity excellently, and you're going to see that the bulb is going to light up there. Right now, they're using the element iron. Now they're using gold. Now they're using chromium, titanium. Okay, can you guys see this video? Please let me know if there's any glitches here. Can everyone see the video fine?
I can, ma'am.
Okay. All right. So the next property of the metal is that it's malleable, right? So we're going to see how a nail is being hammered, all right? But will it break under the pressure? Can you see that? It didn't break. It's just bending according to how we want it. Okay, so I don't know if you guys ever tried this experiment at home, but you take foil, right, and you connect it into an electric circuit. And we see if aluminium is a good conductor of electricity. It should be. Can you see that the light is glowing? Yeah. Okay. I just want to see what else I need to show you guys. All right, now let's try using non-metals in an electric circuit, and let's see if they can conduct electricity. So we'll know if they can conduct electricity if the light starts shining. So in this case, we are using sulfur. Remember that sulfur is also a non-metal. Can you see that the bulb doesn't glow at all, right? They're using another non-metal now. Right, and then if you have to take carbon or sulfur or phosphorus, any non-metal, it's not malleable, so it can't bend and flex and go under strain, right? It's gonna break. Here we go. Right, it's brittle. Okay, let's look at a semi-metal. Remember, a semi-metal has some properties of a metal and some properties of a non-metal. Just going to go back to my notes on that. Okay. Properties of semi-metals. They share some properties of metals and some of non-metals. Example, silicone is brittle, which means it breaks easily like a non-metal, but it's a good conductor like a metal, right? So I think these guys are really lucky because they share the best of both worlds. If we look on the periodic table, remember the ladder I was speaking to you guys about? This ladder that is going down here. So boron, silicon, germanium, arsenic. Arsenic is, by the way, an extremely poisonous, naturally existing semi-metal, all right? So you can die if you consume it. Tellurium, polonium, all of these guys here, they are semi-metals. Let's see what happens when we try to put a semi-metal in an electric circuit. All right, so here we are using silicone, all right? As you can see, the bulb is lightly shining. It's not much of a shine there. It's not like it's not glowing brightly, but it's still a conductor of electricity. So it's still regarded as a semiconductor or semi-metal. Okay. Right, so I'm going to go back to the notes now. And I have a little a short activity that we can do together. All right. I want you guys to identify for me which element is in row 2. Okay, just identify an element that is in row 2 and write it in the chat. So, yes, Mo, beryllium is excellent. Okay, let's see what, yes, Michael, everyone's choosing BE. Lithium, good, good, Lisejo. Okay, now I want you guys to choose for me an element from row, row 1. Remember, rows run across. Good, Gabby, Michael, Christopher, helium and hydrogen. There are only 2 elements in the first row. Okay, now let's go on to a little bit more challenging one, groups. Name me a element from group 2. Remember, groups run downwards. Good, Michael, beryllium. Yes, and remember to use your capital letters now. Magnesium, barium, very goodly. Gabby says SR. Good. Lesejo says RA, radium. Very good. Okay, let's do another one. Name me an element from group 17. Good. Fluorine. There we go. Bromine. Excellent. Okay. Iodine. Excellent. Right. Let's do another guess here. I want you guys to tell me which group, right, and which row is the element oxygen. Which group and which row is the element oxygen? So oxygen is, I'm not going to tell you where it is, you need to look for it. Which group and which row? Christopher says group 16, row 2. Excellent, guys. Yes, it is row 2. Good. Okay, let's look for another one. I want you to look for calcium. Calcium is Ca. Tell me which group and which row it's in. Start with group and then tell me the row. Michael says, okay, no, that's the previous answer. So you're looking for calcium. Gabby says, group 2, row 4. Excellent, Gabby. Well done. Yeah. Okay, guys, let's look for, let me give you a difficult one this time, okay? Are you ready? Let's look for gold. Tell me what group and what row gold is in. Yes, Lee, let's hear. Okay, Christopher says group 11, row 3. It is in group 11, but it's not row 3. Row 6, group 11. Excellent, Gabby. Okay, guys, I hope that was fun. It was fun for me. I like testing you guys. We're going to do one more, all right? So I'm going to point to an element that is either a semi-metal, a metal, or a non-metal, right? And you guys are going to have to tell me what is it. Is it a metal? Is it a non-metal? But I'm going to tell you, I'm going to give you properties of those elements. I'm going to say, is this element shiny? And then you need to register in your brain that, yes, this element is shiny. So I'm going to ask you, is it a metal? All right? And then you're going to tell me. Okay, so just choosing an element. Okay, would I be correct to say that chlorine, right over here, is a bad conductor of electricity? In fact, it doesn't conduct electricity at all. Yes, excellent, Gabby. That was very fast. Let's look at iron here. Would I be right to say that iron is a bad conductor of electricity? It doesn't conduct electricity. Yes or no? Good, no. What about hydrogen? And you guys need to think about this one. Hydrogen right on the top here is an excellent conductor of electricity. Good, no, because it's a gas, right? And you guys may be asking, why is hydrogen in the metal section when it's a non-metal? Basically, hydrogen is a group on its own, right? It's the only element that can be totally individual, right? I don't know. I think they just put it in here according to the amount of elements on the outer orbitals, right? But we'll come to that later. So just don't get confused with that one. All right, one more question. Palladium over here. Would I be right to say that palladium is brittle? Who is drawing squares on my screen? Guys, can you guys access the whiteboard as well? That is really cool. We should experiment with that. So can you guys write something on my whiteboard? Ooh, who's doing this? Who's writing? Okay, I can't read your name. Tell it to me in the chat. Okay. All right, so let's move on, guys. We are nearing the end of our lesson. Please do not write on the board anymore. But I think we should have an activity where we can write on the board all together. Okay, does it mean that metals make up most of the Earth as 3/4 of the periodic table are metals? No. In fact, the Earth's crust has more oxygen and silicon atoms than the rest of the elements put together, right? So if you took all the other elements, metals and non-metals, right, and it wouldn't amount to how much oxygen and silicon is in the rocks and soil. And the universe is mostly made out of hydrogen. When I talk about the universe, I'm talking about like the galaxies and the Milky Ways and black holes and all of that. They are mostly made of hydrogen atoms. Okay, guys, then I need you to complete this activity here. Is everyone understanding how I need you to answer the activity and upload it onto Google Drive? If you're understanding, please write yes on the chat so I know what's going on. Okay, Michael's understanding. Tell me what you're not understanding, Ted. What are you confused about?
Like, man, it's like man. So we get this off Google Classroom, man. And then like we answer. Must he send you a picture, ma'am? Or like, how do we like? Where do we write it? Like, in those boxes. And then we write, okay, sorry, I get it, ma'am.
Okay, so guys, I've created the Word document in such a way that you guys can't access any other part of the document. You can't copy or paste, but you can click and type your answers. Oh, what happened there? Here we go. You can just click and type your answers in. Okay, it's that simple. And that's how you guys are going to write your exams as well. All right, so I'm going to give you a document just like this, and you won't have answer sheets. You're just going to write your answers on the document. Christopher says, yes, but do we have to put it on shared files? Don't worry about putting it on shared files at the moment. You can just add it to your Google Drive, and at the end of the week, let's say this week, Friday, all of you, each and every one of you, is going to send me a link to your Google Drive so I can check all the activities you've been doing in the week, and I can give you feedback on that. Okay, I'm going to put up a video on Google Classroom explaining in detail how to access a Word document, how to edit on Google Drive, and all of that. Okay, if you don't know how to create a folder on Google Drive, I have also created a video on that, so check it out. It's on my Google Classroom. Okay, guys, let's look through the activity quickly. You need to, it's my pleasure, you need to complete the table of differences between metals and non-metals. You need to tell me what a vertical column is called. And then you need to guess the elements in A, B, and C. Number 4 says you need to tell me the significance of the atomic number of an element. When I ask you for the significance of something, you basically need to tell me what is its meaning, all right? What does it stand for? What does it tell me? Then number 5 says, what is the significance of atomic mass? And we've done this in the previous lesson, so just refer back to that. Number 6, what are the subatomic particles of an atom? We know that those are, what is the atom made out of? So electrons, protons, and neutrons. And lastly, what is a neutral atom? Who can answer this one for me? What is a neutral atom?
May I please, ma'am?
On the chat.
Yes, ma'am.
A neutral atom is an atom that has the same amount of protons as it does electrons. Excellent, first of all. So all your atoms on the periodic table, all of them are naturally neutral atoms. So they have the same amount of protons and the same amount of electrons. All right, we're going to go in depth in that topic in the next lesson. And yeah, for this lesson, we are done. Guys, please make sure that your homework is completed every week by Friday. Okay, so in that way, I don't make it due like for the next day. It's not taxing for you guys. But just make sure that everything is done for Friday and upload it onto your Google Drives so that I can access those files. Okay, have an awesome day. And I'm going to change the time. Yes?
Thank you, ma'am. Thank you so much.
I have one more thing to say, though. I'm going to be changing the timetable so that you guys start maybe a little earlier and end early, because I think 4 o'clock is too late now. Maybe we can end at like 3.
Ma'am, I don't wake up early.
Yeah, man. Waking up early is the man. It's even difficult to
Yeah,
wake
me
up.
neither, ma'am.
So is this
Nah.
fine? Are you guys happy?
Yeah.
Yes, ma'am.
Yeah, man, it's better than waking up earlier, man. Because hey, I think we were.
Okay, so
Yes.
what I'm going to do is I'm going to start you guys off at 9 and try to end you at 3. Okay.
Yeah,
Okay.
thank you.
Okay. But then
Thank
the
you, ma'am.
downside of that is you won't receive many breaks in between. Is that okay?
Okay.
Yeah, it's better. It's better. It's fine, man.
Thank you so much for your time, ma'am.
All right. Bye.
Thank you, ma'am.
Yes, ma'am.
Bye.